You are welcome back to Jewel's Study World. Today our lesson will be on matrices. Yes, matrices. Introduction to matrices. So before we begin the matrix as a topic, you have to first know some terms in matrices. Yes, and this video will be based on that. This video will be on introduction to matrices. So we are saying that matrices are in many senses similar to vectors, except that whilst vectors are represented by columns of numbers, matrices are generally blocks of numbers made up of number of rows and columns. So we are saying that matrices represent vectors, but the difference is that for vectors, they are written as columns of numbers like this. You have maybe 2, 3. This is a vector, or maybe you have A, B. This is also a vector. But for matrix, we are saying that they are represented by blocks of numbers. So we have maybe A, or let's say 1, 2. Yes. Which have number of rows and columns. Yes. It can also be like this. Maybe 1, 2, 3, 4. Something like this too. This is also a matrix. It's a block, and it has number of rows and also columns. So you are saying that the horizontal array are the rows. So the horizontal arrays, these are the rows. So this matrix has 2 rows, and the vertical arrays are the columns, and these are the columns. So 2 rows, 2 columns. And we name the matrix. We name the matrix by first mentioning the number of rows times the number of columns. So we name it by first mentioning the number of rows, then you also mention the number of columns. So this matrix, it has 2 rows. So it is 2 by, then it has 2 columns. 2 by 2 matrix. For this one too, it has 2 rows. So it is 2 by, it has 1 column. So 2 by 1 matrix. This is how to name the matrices. Yes. Let's continue. So we are saying that now how can we address the matrix? How can we address the matrix? So let's take it as we have this example. We want to know how to address the matrix. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have this matrix. This matrix is a 3 by 3 matrix. 5. We have rows times the columns. So number of rows 1, 2, 3. It has 3 rows times number of columns. We have 1, 2, 3. Times 3 columns. So 3 rows, 3 columns. So it's 3 by 3 matrix. Now, we want to know the address of the matrix. Like maybe these entries, the ones in the matrix or the values in the matrix, they are called the entries. So the entry, they are called the entries. So this matrix 1 or the entry 1, this entry 1. How can we name the matrix, or how can we address it? How can we address 1? We can address 1 by saying that 1 is equal to, we are saying that 1 is equal to A11. A11. The first one is showing the row in which 1 is, and the second one is showing the column. So 1 is in the first row. That's the first one. And then this same one is in the first column. That's the second one. Yes. Now how can we address 2? So 2, we can address 2 by saying that 2 is in the first row. So we have A2. Then this 2 is at the second column. So we have first column, second column. So it is 2, 2. So 2 is in the first row. So 2 is in the first row. Yes. First row. And it's in the second column. So first row, second column. This is how to address 2. A, 1, 2. Now for the 3, how can we address 3? So let's address 3. So 3, so we first write the A. 3 is in the first row, so 1. Then 3 is in the third row, so third column, sorry. So you have first row, second row, third row. So 3 is in the third row. So this is the address of 3. You have A, 1, 3. So note that it is row times column. And the rows are the horizontal arrays. And the columns are the vertical arrays. So let's try naming the 5. So what's the address for 5? 5 is in the second row. So you have 1, 2. So second row. 5 is in the second column. So you have 1, 2. Second column. Yes. So this is the address for 5. Let's address 8. Let's address 8. So 8. So you have 8. Now what is the row of 8? 8 is in the third row. You have 1, 2, 3. 8 is in the third row. Now the column 1, 2. The second column. This is the address for 8. Now let's name the 9. For 9 too, you have 9 is in the third row. So 1, 2, 3. 9 is in the third row times. So third row. Now the column of 9. You have 1, 2, 3. It's also the third column. So this is how to address the matrices or the entries. Yes, these are the entries. How to address them? The address. Let's continue. So now we've moved on to square matrix. So square matrix. Square matrix. So we are saying that a matrix is said to be a square matrix if it has the same number of rows and columns. So if the matrix has the same number of rows and columns, it's said to be a square matrix. So let's say you have A, B, C, D. This matrix, let's call this matrix A, and let's call this matrix B. C, D, E, F. So let's take these matrices. Now we are saying that a matrix is said to be square if they have the same number of rows and columns. So for this matrix A, let's check if matrix A is a square matrix. How many rows does A have? 1, 2. So it has 2 rows. Now, how many columns does A have? 1, 2. So 2 columns and 2 rows. So since matrix A has the same number of rows and columns, matrix A is said to be a square matrix. Now for matrix B, let's check the number of rows that matrix B has. So matrix B, it has 1, 2. So 2 rows. Now how many columns? Just 1 column. So 2 by 1. Since matrix B has different number of rows and columns, it cannot be said to be a square matrix. Let's continue. So we are saying that a square matrix or a matrix can only be a square matrix if it has the same number of rows and columns. So we are saying that 2 by 2 is a square matrix. 3 by 3 is a square matrix. 4 by 4 is a square matrix, and so on. Now let's continue from here. So let's move on to equal matrix. So we have equal matrix. Equal matrix. Equal matrix. So two matrices are said to be equal if they have the same dimensions and same corresponding elements. So for equal matrix, Let's say you have A, B, C, D, E, F, G, H, I as matrix A. And let's say you have matrix B to be 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And you are saying that matrix A is equal to matrix B. You are saying that these two matrices can only be equal matrices or equal matrices if they have the same dimensions. If this is 2 by 2, this should also be 2 by 2. That's the first condition. Now the second condition is that they must also have the same members. So if they are saying that this matrix A is equal to matrix B, then we mean that A is equal to 1. Yes. For matrix A, it has 3 rows and then 3 columns. For matrix B, it has 3 rows and then 3 columns. So one of the conditions is checked. Now the second condition is that they must also have the same number of elements or number of entries. So you are saying that A is equal to B. It means that matrix the entry A is equal to 1. So A is equal to 1. Matrix B, the entry B is equal to 2. B is equal to 2. C is equal to 3. I is equal to 9, and so on. So these are equal matrices. Let's check this one too. So let's say we have A is equal to 1 A, B, C, D, and then B is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Matrix A and matrix B cannot be equal matrices in any way because they have different dimensions. Matrix A is 2 by 2. It has 2 rows and 2 columns. Matrix B is 3 by 3. It has 3 rows and then 3 columns. So since they have different dimensions, they can't be equal matrices. Yes. But matrix A alone is a square matrix because they have the same number of rows and columns. Matrix B alone is also a square matrix because they have the same number of rows and columns. But matrix A and matrix B are not equal matrices because they have different dimensions. Yes. Let's continue. So we're moving on to zero matrix. Zero matrix. Zero matrix. So we have zero matrix. This is a matrix which has each entry as 0. So for a matrix which has all the entries as 0, then the matrix is called zero matrix. So let's say we have matrix A to be equal to 0, 0. All the entries in the matrix are 0. So matrix A is a zero matrix. Matrix B, we have 0, 0, 0, 0. This is a zero matrix. Matrix C, we have 0, 0, 0, 0, 0, 0, 0, 0, 0. This is a zero matrix. Yes. So all the entries are 0. These are zero matrices. Let's continue. Now we are moving on to the addition and subtraction of matrices. Addition and subtraction of matrices. Addition and then subtraction of matrices. Addition and subtraction. So addition and subtraction. Of matrices. So two matrices can be added or subtracted if they have the same size or they have the same dimensions. So you can only add or subtract matrices if they have the same dimensions. So let's say we have matrices. So what we mean by this is that we can only add 2 by 2 matrix to a 2 by 2 matrix, a 3 by 3 to a 3 by 3, not a 2 by 2 to a 3 by 1, or a 2 by 2 to a 4 by 4 matrix. No, just if we have 2 by 2, add it to 2 by 2. Yes, so we can add and subtract matrices of the same size or the same dimension. So let's check these examples. So we have, given that you have matrix A to be A, B, C, D, and matrix B is equal to E, F, G, H. We can add matrix A to matrix B. Why? Because they have the same dimensions. Matrix A is a 2 by 2 matrix. It has 2 rows and then 2 columns. Matrix B, it is also a 2 by 2 matrix. It has 2 rows and then 2 columns. So since they have the same dimensions, we can add them. So matrix A plus matrix B is equal to, so you add each entries. So matrix A plus matrix E, so you have A plus E. This will be the first entry of our result. For this side too, we have matrix B plus matrix, we have entry B plus entry F. So we have B plus F. This side too, we have C plus G, C plus G, and then we have D plus H, D plus H. So this is how to add or subtract. If we were to subtract 2, we have A minus B is to be equal to A minus E, B minus F, C minus G, D minus H. So this is how to add and subtract. Note that we can only add and subtract matrices of the same dimension or the same size. Now, let's take this example. So our first example, we have given that matrix A is equal to 4, negative 5, 0, 4, negative 6, and then 1. And then matrix B is equal to 3, 2, 7, negative 4, negative 2, 1. We are to find PA plus Q, Q plus P, A plus B, sorry, you have A plus B, B plus A, and then we have A minus B. So let's check if we can only add and then subtract if they have the same dimensions. Let's check. Matrix A has 3 rows and 2 columns. Matrix B has 3 rows and 2 columns. So this is a 3 by 2 matrix and then 3 by 2 matrix. So since they have the same dimensions, we can add or subtract them. For the first one, we have A plus B is equal to 4 plus 3, negative 5 plus 2, 0 plus 7, 4 minus 4 plus negative 4. We have negative 6 plus negative 2, 1 plus 1. Now let's simplify this matrix. So 4 plus 3, we have 7. Negative 5 plus 2, we have negative 3. 0 plus 7, we have 7. 4 plus negative 4, we have 0. Negative 6 plus negative 2, we have negative 8. 1 plus 1, we have 2. So this is the result of A plus B. Now, let's check B plus A. So B plus A will be like we have B plus A. So the B will come first, 3 plus 4. So we have 3 plus 4, giving us 7. Then here we have 2 plus negative 5, giving us negative 2. So B plus A and A plus B gives us the same answer. So this shows that addition is commutative in matrices. Yes. Now let's check the last one, A minus B. So A minus B, so we have matrix A minus B. So A minus B, so 4 minus 3, and then negative 5 minus 2, negative 5 minus 2, 0 minus 7, we have 4 minus negative 4, we have negative 6 minus 2 minus negative 2. We have 1 minus 1. So let's simplify this matrix. A minus B is equal to, so 4 minus 3 gives us 1. Negative 5 minus 2 gives us negative 7. 0 minus 7 gives us negative 7. 4 minus 4 gives us 0. Gives us 8 plus, so we have plus, so 8. So negative 6 minus negative 2 gives us negative 4. And then 1 minus 1 gives us 0. So you have to note that since the question gave you 3 by 2 plus 3 by 2, your answer must also be 3 by 2. So let's check our answer here. We have 3 rows, 2 columns. So our answer is also 3 by 2. This one too, we also have 3 by 2. Yes. So this is how to solve addition and subtraction of matrices. So this brings us to the end of today's lesson, Introduction to Matrices. Make sure to like, share, and then subscribe to my YouTube channel. This is Jewel's Study World. Bye bye.